Okay, so let's try number 48 in the exercises of section 2.4. So we're given three sets, right? Three proper subsets, A, B, and C. And then we're given the universal set. And again, these elements could represent maybe 9 students in a class. It could be anything. But I mean, I know we talked about the students in the class, and so in this case you can think of it as 9, but it doesn't have to represent that. So the goal here is to construct, okay, a Venn diagram illustrating the given sets. Okay, so the goal here, the way you want to begin this is you want to start off by finding the four intersections, the innermost intersections that we found. We talked about 8 regions, so we want to find the innermost. So let's go ahead and write that out. So I want to find A intersection B intersection C. Then I want to find A intersection B. Then I want to find A intersection C. And then finally B intersecting C. And there's no specific order to this. I just chose it in this order. I usually encourage you to find the intersection, right? That's, I mean, all the elements that are common to all sets first. And then these guys, it really doesn't matter. But here's the kind of big picture here, or maybe our visual representation. So here we have a set A, right? Call that A, right? Here's set B. That's a B. And here's set C. And so this first intersection, I think I labeled it green last time, right? So this guy, I want to know what elements live in there, right? And I don't know, maybe A intersecting B. Well, A intersecting B is all of this, right? Including that green. Let's see, maybe purple A intersecting C. So we have, right, A intersecting C. What they have in common is these guys, right, whatever these elements are, or that region. And then finally, then maybe get, how about blue? So the intersection of B and C, and the intersection of B and C is, oh, maybe I should get a different color. Maybe, let's do yellow. If I can find my yellow, okay, there's my yellow. So let this be yellow, and that's going to be this guy right there. Okay, so these are the 4 intersections that I'm talking about. 1, 2, 3, and 4. Right, and then of course you have 5, 6, 7, and then 8. But again, this could be 1, 2, 3, 4, or you can start 1, 2, 3, 4. It's just a labeling thing. We want to make sure we're referring to what region we're talking about. Okay, so that's the idea. So now let's go ahead and start by finding these, by finding these guys, and then we'll go ahead and draw the picture. Okay, so let's, the intersection of A, B, and C. Let's see, let me go back to white. Okay, so A intersecting B intersecting C. What do they have in common? Well, A, B, and C, A, B, C, looks like X, A, B, C, so X3, 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 X9, actually no X9. The only thing in common is X3, X3, and X3, right? These 3 in common to all A, B, and C. Okay, so I definitely know that this guy is X3. Okay, so then I move on to the intersection of set A and B. Okay, so only A and B. So we go back and let's see, A and B. Well, we definitely know X3 is in common. And I think that's also, A and B is also X3. Let's just double check, right? X3, 3, 3, but A and B, yep, only X3. So X3. And let me just double check. I mean, that could happen, but it doesn't have to be 9, 9. Yep, that's it. Okay, so they're both singletons, which is fine. The intersection of A and C. So what do A and C have in common? What elements? And so here's A and here's C. So it looks like 3 and 9 here, right? Because we have that 9. So 3 and 9. So x3 and x9. And then finally, the intersection of B and C. Okay, so BC, and our BC is right here. So it looks like x3. So x3 and x3, x5, and x6. So 3, 5, and 6. So 3, 5, and 6. Okay, so that's the first kind of big step to find these 4 intersections. So find 4, right, innermost intersections. So now let's start drawing our Venn diagram. Let's start filling in the information that we have. Okay, so I'm going to make the Venn diagram pretty big just because we're going to need that. So I'll go ahead and move. I'll scroll up again. Okay, so here's my universal set. Okay, and then I have A, I have B, and I have C. So A, B, and C. And on your ICA, make sure that, I mean, I don't just want to see this with, of course, the answers on it, which is in the back of the book, or your test. This is, I mean, not going to give you much credit, right? I need to see, again, your thought process. I need to see how you found this information. I need to see everything above as well. Okay, so, well, since we're here, right, what do they have in common, right? Only x3. So again, start from inner to outermost. So this is definitely x3 because that's all A, B, and C have in common, right? And then you're going to have these regions right here, right? This piece, right? You're going to have this piece, and then you're going to have this piece. Oops. Right? So we want to fill in these guys, right? These are the other A, you know, here's A intersecting B, A intersecting C, and B intersecting C. Okay, so A intersecting B is x3. Okay, so here we have, okay, set B, and what do they have in common? Well, the only thing they have in common is x3, which is already there. And be careful not to, so that's why you want to start with the innermost, because if you started with A intersecting B, some students want to write it here, but I mean technically, well, I mean x3 does live in C, so it really needs to be here. So there's nothing really else we can do here for that part. So well, let's see, color coding. What did I label it? So my red, A intersecting B. I might as well let's do the colors. That hopefully helps. Right, there's that part. Okay, the next one, that wasn't it. Yes, it was. A intersecting B. Okay, purple. So this guy, A intersecting C. Okay, so that's going to be purple. A intersecting C is 3 and 9. Okay, so purple, x3, and 9. Oh, I already forgot what set. A and C. Okay, let me leave that right there. So A and C, here's A, right? And then C is right here, right below. So A and C, well, they intersect right here, right? Or the purple. So they have 3 and 9 in common. So this piece right here, well, there's a 3. So we have to add that 9 in there. Okay, so that's the, let's see if I have that purple open. I don't know if it's the same purple, but right, there's that that purple piece right there. Okay, which, I mean, does include this guy here, but again, that x3 is very specific. That's the only element that's in common. Okay, so let's see, and maybe let me, again, I don't want to confuse you here. Let's make that in green. Okay, so the last one is a B intersecting C, right? Because we already did this guy. There's nothing else in common. That's why x3 was only there. So B and C. So here's B, here's C, and 3, 5, and 6. So BC is right here, and I think I chose yellow. So, right, there's my yellow, and I have, let me go back to white. 3, 5, and 6. Well, 3 is already part of that, so x5 and x6 is right there. So that's an x5 and that's an x6. So I've filled the 1, 2, 3, and 4 regions, right? There's nothing else in here. And our final step is to find, or to fill in, get my pointer here, is to fill in this guy, right? This piece of A, this region, and then this region, and then finally this region. And of course, right, all this space as well. So let's just look at what set A is. Okay, well, set A was 3 and 9. Okay, so if we go back, 3 and 9, does set A have 3 and 9? Well, here's A, all of this, and it actually does contain the 3 and the 9. There are no extra elements, so that's done. The next one is B, and B is 1, 2, 3, 5, and 6. So 1, 2, 3, 5, and 6. So 1, 2, 3, 5, 6. So here's x3, 5, and 6. Oh gosh, what was the last one? I already forgot. X1. Okay, 1, 2, 3, 5, and 6. 1, 2, 3, 5, and 6. So I'm missing 1, 2, right? And then there's 3, 5, and 6, right? B contains all these elements, okay? And again, this one's empty. And finally, set C is, let's see, 3, 4, 5, 6, and 9. Okay, 3, 4, 5, 6, and 9. 3, 4, 5, 6, and 9. C is right here. 3, we need a 4, 5, 6, and 9. So we add that x4. And I think we already did an A, so what do we have here? So we have x1, x2, x3, x4, x5, x6, and x9. So are we missing any? Well, what's our universal set? Our universal set is x1 all the way through x9, right? Consecutively, 1, 2, 3, 4, 5, all the way to 9. So we should have all those x terms in there. So let's see, let's move back down. And so again, the final step here, 1, 2, 3, 4, 5, 6. So 7 is going to be out here, x7 and x8. x9 is already in there, and then we're done. Right, because x7 and 8 did not appear in any of our sets. There's no, it's not an A, B, or C, right? It's on the outside of A, B, and C. So that's basically it. And again, if you want to label these guys, you can. Right, this could be Roman numeral 1, 2, 3, 4, 5. It doesn't matter, but that's the idea.